What time is it? 10 o'clock. Good morning, everybody. How's everybody doing today? Huge crowd. Great to see you guys here. Thank you, thank you. So my name is Kriczky. I'm a VP of Products and Services for Teledyne Lecroy. Chandra, he'll be introducing himself. I guess go ahead and introduce yourself.
So Chandra Nelogal, I'm part of Wiwynn, and I focus on data storage and security. And as part of this exercise, we did a more comprehensive look at validation, and that's what we are talking about.
Yeah, so, we kind of titled this, Beyond the Drive, the Strategic Value for, testing NVMe SSDs for a cloud infrastructure. I had a session earlier this morning that was really based on NVMe OCP SSD qualification process, which today, that process really is validating a drive outside of the system. Take a drive, test it in any NVMe environment, it doesn't really matter, and you test to certain OCP requirements. What we're really after today is expanding that testing and going from being just inside of a box to what happens when it's inside that real infrastructure and what happens in real world environments, real world workloads, and we'll talk about some of the failures that we see. So between myself and Chandra, we've been doing quite a bit of testing on the side. We've been doing testing in different environments, bringing out different test solutions that we want to share with the world and get more people involved in it. So kind of as hyperscale data center infrastructures grow, we look for ways to make sure that performance of NVMe SSDs continue to improve. We want to find solutions to get people to work together for NVMe SSD testing. I'm going to move this over just a little so I can see my slides at the same time. So, we're going to talk a little bit why solution level testing matters, how it's different from just standard drive testing, overview the diagnostics that are available. Chandra's going to go in a little bit about some of the difficulties in testing in that full environment. And then we're also going to talk about how to debug and analyze some of these things, some of the real world failures that we see in our test environments today. And then again, why collaboration is important. So NVMe SSD testing, today there's OCP NVMe SSD compliance. You heard a little bit about that in the previous session. There's options from Meta for some of the GitHub options. There's also solutions that we provide. We have a complete OCP NVMe SSD test solution, and that goes through testing PCIe, NVMe, security, performance, power, thermals. It even gets down to little things like how do you label your drive for certain environments. It's a full solution that we've been developing for many years now. It started with OCP 1.0a, now moving into OCP 2.6, OCP 2.7 is on the verge of coming out, so this spec for the drive qualification continues to grow. Jointly developed, Microsoft, Meta, Google, HPE, Dell, all involved in this requirements. So validation of the drive. Each drive is validated as an individual device. That's the thing that we are trying to also take that step further. Let's not just validate the drive as just a device. Let's validate it in the environment that it's going to be used in. Now, the OCP specification, there's a lot of good pieces about that help enable different vendors in order to have a solution that solves their requirements from a hyperscale environment. It aligns all the vendors on kind of a single requirement for what is a drive supposed to do in those environments. And then, it helps get things to market faster, helps save some of the debug cycles, some of the test cycles that go on today between all these different drive vendors. So system level testing, this is taking that next step further. What is involved? Once a drive is OCP compliant on its own, start to incorporate that into your system. Testing in an integrated environment with different operating systems, the CPU, the network, the software layers. I'm hearing more and more about, all these different Ethernet technologies that are now impacting these workloads for the hyperscale environments. and the need to be able to test in those type of environments with those type of workloads. So stress testing, workload testing, AI testing, very important. Then you get into the power, latency, error recovery pieces of things. I'm going to turn it over to Chandra.
So, yeah, I guess I can talk. So here, if you look at it, right, the slide is fairly complex and it's like an eye chart, but the intention is you zoom out, right, as Nick was talking about, and also in the previous session, Meta guys were talking about complete validation test suite. So the test suite is, again, they are focused on SSD, but here, if you zoom out, we are looking at from a whole subsystem, storage subsystem, right? So you look at even a drive, that's a complete subsystem in and of itself. It has, media management, media health management, the data path, the control path, the sideband path, and then the media technology themselves are evolving and improving, and then a whole lot of security items that go into a making of a drive, right? So that's one subsystem for you. Then you have the platform in which the drive is sitting, right? It may be a JBOF, it may be a JBOD, it may be a compute node, but there you have various other system level interactions. You have the high speed protocols, you have the management protocols, you have the storage protocols that which interact with. Also the signaling, sideband signaling, plus you have the system configuration items like the UEFI configuration items, the PCIe configuration items. All of them interact with the drive in some way, shape, or form, right? And they also impact the overall storage performance of a system. Then you get into the software side, and then two broad categories. One is just a host software, right? You have the operating system or a hypervisor, then you have virtual machines, containers, and you have in the operating system, you have multiple layers of your driver stack and the IO scheduler. All of them, they influence the drive and the functionality of the drive, right? And then cluster, right? Cluster software, it's a lot more higher level, but at node level, you have redundancy, you have failure domain, and the data placement algorithms have to comprehend the failure domain across the nodes, across the network. All of that has to be in place, right? So what we did is we took all of these four big umbrella terms and thought about, okay, how can you apply debuggability? How can you apply diagnostics into each one of them? And good path testing, everybody does, right? Everybody already has test suites. They test for the correct functionality of every component, every software component. And we talked more on the side of the error handling. So what we did is, again, this is like a loop. So we looked at identification of different failure modes, assess the effect of such a failure, right? If failure X happens, what is the observation? What do you expect to see? How the system is expected to behave? What is Y? And then identify the different causes for the failure and simulate them and define the control. What is the bound of a test? We did that. And this is kind of a very high-level list of items, right? So in fact, what we have is more than 100 list of detailed items, and each one of them has a test procedure which runs into multiple pages. But this is like a high-level summary of what we did, and you can see this in our booth as well. So look at, again, you look at the complexity diagram, and you narrow it down into, okay, drives, then you have platform items, then you have sideband items, manageability, then you look at the NAND media health and media exhaustion conditions, various conditions, error conditions we simulated. We wrote a test line item, wrote a test procedure, executed it, and see the observation of each one of them. That's all in the hardware kind of a bucket. And then the software bucket, again, all the way from the low-level driver to mid-layer or the store port, introduced various parameter changes and drove that as well, along all the way up to the cluster-level software, right? We did multiple cluster-level software, different cluster-level software we used to simulate these error conditions. and go from there, right? So that's what we did. And on the security realm also, we did take some of the security related test cases, mainly around corrupted firmware or unsigned firmware situations. Some of the hardware root of trust, we wanted to exercise those code paths. Although at a device level it would have gone through, but we did come up with those test cases. So again, this is like a kind of a summary of the same thing that we talked in the past, but it's again, you take up a component and then you look at various error conditions that it can get into and then simulate that error conditions. And as I said earlier, it's like more than 100 items, like maybe nearly 110, 115 items that we could do at a compute node level. Now, if we added an EBOF, if we added a JBOF, it would explode. But part of this scope was at a compute node level. With that, let me turn it back over to Nick.
Yeah, so I kind of gave a brief introduction of who I am. There's a lot of tools that are required in order to be able to support this type of testing. So I represent Teledyne Lecroy. Teledyne Lecroy is known for some of their test and measurement tools, anything from oscilloscopes to protocol analyzers. But specifically in the work that we were doing for this project and some of the use case requirements around it, things like protocol analyzers, error injectors, Ethernet packet generators, we use those in order to simulate high-speed AI hyperscale environments to test in the true environment of what we would see probably more in the real world. The benefits of that is the analyzers themselves give you that deep visibility into what's going on the link, being able to capture things that may go by unnoticed. Small hesitations, longer latency, things like that get missed by the naked eye most of the time. So using the right tools in order to provide this type of testing is important. The use of analyzers, jammers, stress tools, kind of similar to the slide previously, simulates that real world interference and contention on the link, helps validate system resiliency.
So if I can interject just for a minute. So in terms of the jammers, right, so we did a lot of creative use of various jammers for error conditions, right? For example, you have SCSI, right? We created a condition which would make the drive fail a IO command, but then we did a lot of manipulation of the sense data that is thrown back from the drive. Not just one condition, but out of one condition, we can simulate like a dozen additional conditions that the operating system has to see, right? So that's kind of the creative use of the jammers we did both on the SAS side, NVMe side, towards this error injection.
So we're down to the last couple minutes, so I'm going to run through a couple slides here real quick. We've kind of run through what we did from this case study perspective, where we did a full setup configuration in our lab, ran these tests with the different solutions, different systems, working with the Wiwynn team, and then creating these instability tests in order to really determine how different parts of the system react and how it might affect the OCP SSDs. We also did monitoring of key metrics, setting up these SSDs in multi-host OCP configurations. We used the tools in order to manipulate what was going on the link, and then we would measure and mark what's happening for different things like what's happening under latency load, error recovery times, protocol compliance and retries, and certain clustered and VMware type configurations. Overall, so the Teledyne Lecroy Austin Labs is an OCP experience center. It gives a chance for people to come to our lab and work with us on different environments just like this. We provide a lot of the essential tools in order to be able to do this testing. Between Chandra and I, we're helping the industry to be able to grow and be able to expand the testing that they're doing. So, we're always open to opportunities to work with you and your teams. On the call to action, it's really all about collaboration. There's a lot that's going on in the OCP environment. There's a lot of new technologies that are happening. There's a lot of new spec updates that are going on, especially around the SSD drives. Get involved with everything that's going on the in the OCP front. There's the OCP test and validation work group. There's a link to it in my slides so you can sign up and get involved with that. There's the OCP storage working group. They meet once a month, but we're in the process of bringing out the OCP 2.7 specification, and there's a great opportunity for you to get involved and provide feedback into that specification, and then work with experience centers like what Austin Labs is. As you walk in the front door coming into the facility here, there's a big map of the world that shows where all these different OCP experience centers are across the world, and you can look and you can see ours, Austin, Texas. I invite everybody to come visit us there. We've got great barbecue and a great opportunity to learn and grow what we do. Thank you.
We have a little bit of time for quick questions. Awesome. Thank you.
Thanks, everybody.